Good morning to all of you. Today I am recording the lesson on force systems. So this is a lesson for day 15. So we are going to discuss about the parallelogram law of forces. For this, for that I have prepared the PPT and now I would like to share the PPT to have the discussion on the lesson. So in the force systems, today we discuss about the parallelogram law of forces. So in this lesson we are going to discuss about the parallelogram forces. So before that, in the recapping the previous lessons, in the last classes, we have been discussed about the system of forces and to find out the resultant of a force system, and we have defined the equilibrium, and also we have known the conditions for the equilibrium. So now in this class we'll discuss about the parallelogram law of forces. Now in this class we are going to discuss about the parallelogram law of forces. So in this we can find out, we will derive an equation for the magnitude and direction of the resultant, and also we will see the method of resolution for calculation of the resultant, that is for both magnitude and direction of the resultant. Now this is the parallelogram law of forces. So it is a very important law, and it will give the equation to find out the resultant of a force when two forces are acting simultaneously at a point. That means two concurrent forces are acting in different directions. If you know the angle, if the forces are known and the included angle is known, then we can able to find out the resultant of the that two forces in both magnitude and direction. So we know that what are the concurrent forces when two forces are acting, when two forces are acting at a point, or they are meeting at a point, then they are said to be called as the concurrent forces. And here also the same thing. So we'll going to find out the resultant of the two coplanar concurrent forces. That means there are two conditions. The force must be act in the same plane, that is the coplanar, and also they should act at the same point. So the origin of the forces must be same. Then we can able to find out the resultant of that two forces by making use of the parallelogram law of forces, and like this. So this is the definition. So here the force P and the force Q are acting at point O and with an included angle alpha. So the resultant of the force P and Q, that is R, can be found by this parallelogram law of forces. Now we'll see the definition. If two forces are acting at a point or be represented in magnitude and direction by the two adjacent sides of a parallelogram, then the diagonal passing through the point of interaction represents both in magnitude and direction of the resultant of that forces. That means when two forces are acting at a point are represented by the two adjacent sides of a parallelogram, then the resultant of these two forces can be represented both in magnitude and direction by the diagonal of the parallelogram, which is passing through the point of intersection of the two forces. So this is the statement of the law. That means here now we'll see the explanation of this parallelogram law of forces. Let the two forces P and Q acting at point O, that is a common point. So they are acting from the common point O. That means they are meeting at the point. So we can say they are the collinear forces. B represented by a OA and OB. That is the two sides. So P is represented by the horizontal side of a parallelogram and Q is represented by the OB side of the parallelogram. Here the Q makes some angle alpha with P. Then the resultant of these two forces can be represented by the diagonal. Here OC. So we got the OA and OB two sides of the parallelogram. So with these two sides we can complete the parallelogram OA BC or OA CB. Here because OA is in the parallelogram, OA is equal to BC and OB is equal to AC, because in the parallelogram the opposite sides are equal. So we can construct the parallelogram OACB with the given sides, that is OA and OB. Now after completing the parallelogram OACB, then we will extend the side OA to OD. So that is, so OA is extended up to point D, and now we have to draw a perpendicular from point C on OD. So we have to extend OA to point D and draw the perpendicular on it from the point C. Okay. Now we know that the angle between the P and Q is alpha. That is the angle AOB is equal to alpha. When the angle AOB is equal to alpha, we also know that because the side OB and side AC are parallel, therefore the angle here, the angle CAD also equal to angle AOB. So that is nothing but the alpha. So the angle CAD and angle AOB both are same, and that is equal to alpha. And also in the figure, the sides AC is equal to OB, that is equal to Q. That is because the OB is represented by the force Q, and similarly OA also equal to BC, and that is also equal to force P because it is represented by the force P. Now the R is acting along the diagonal, and it makes an angle theta. So theta is the angle made by the resultant force with the horizontal, or we can say with the force P, because generally one side of the parallelogram is horizontal and the other side makes some angle with this horizontal side. So generally the bigger force is taken as horizontal side, and so the resultant, whatever the angle made by the resultant, so that is the angle made with the horizontal. Here the R is the magnitude of the resultant force, and theta is the angle made by the resultant with the horizontal. So that is the direction of the resultant force. And here generally the lengths are parallel to the magnitudes of the forces. Here the OA is proportional to the amount of force P, and similarly the OB is equal to the OB is proportional to the amount of force Q, and here the P value, Q value will not be given, but however the force P is having more magnitude than the force Q, that is P is greater than Q in this case. Now from the figure we know that CD is equal to AC sin alpha. So this CD, that is CD is equal to AC means that is the one of the side of the parallelogram, that is known side, that is equal to Q, and alpha also known. Therefore here in the triangle CAD, the sin alpha is equal to CD by AC. Therefore CD is equal to AC into sin alpha. Similarly, the triangle CAD, cos alpha is equal to AD by AC. Therefore, AD is equal to AC into cos alpha. So, CD is equal to AC into sin alpha, that is Q into sin alpha, because here the AC also equal to OB. So OB is nothing but the given force Q. Therefore, the CD is equal to Q into sin alpha. And similarly, the AD is equal to AC into cos alpha. Here AC means Q. So Q into cos alpha. So CD is equal to Q sin alpha, and AD is equal to Q cos alpha. And now this in this triangle, the bigger triangle, bigger right angle triangle, that is we got the OCD. OCD is the bigger right angle triangle. So according to the Pythagoras theorem, the square of the hypotenuse is equal to square of the opposite side plus square of the adjacent side. So here r square is equal to the diagonal OC whole square is equal to OD whole square plus CD whole square. Here that is nothing but the OC is nothing but the R. So R square is equal to CD whole square plus OD whole square. But here we know the value of the CD, and this OD is nothing but the, we can write OD is equal to OA plus AD. So we know the OA value, that is P, and AD value, that is Q into cos alpha, and we know the CD value, that is Q into sin alpha. Now we can substitute that values. So in the ODC, OC square is equal to OD square plus CD square, and here OD we can write as OA plus AD whole square plus CD square. Therefore R square is equal to P plus Q cos alpha whole square plus Q sin alpha whole square. Now expanding that equation, R square is equal to P square plus Q square into cos square alpha plus 2pq into cos alpha. That is the first term. That is nothing but the OD value. That is the OD square value. Now the CD is nothing but the Q sin alpha. So CD square is equal to Q square into sin square alpha. Now here we got the common terms. So by seeing this equation, we know that Q square is having the common terms. So Q square is the common. So therefore first one is the P square plus Q square into, we got cos square alpha plus Q square into sin square alpha. If we take common as Q square, then cos square alpha plus sin square alpha plus 2pq into cos alpha. And according to trigonometry, we know that the value of the cos square alpha plus sin square alpha is equal to 1. We know the equation, sin square alpha plus cos square alpha is equal to 1. Therefore this is equal to p square plus q square into 1 plus 2pq cos alpha. So this is nothing but the r square is equal to p square plus q square plus 2pq cos alpha. So this is nothing but the, that is the square of the resultant, that is the r square value. But we should find out the r value. So when we know the r square value, so it is very easy to find out the r value. We know that r is equal to the square root of that value. So r is equal to square root of p square plus q square plus 2pq cos alpha. So this is the equation for the resultant, that is the magnitude of the resultant of the force of the given two forces P and Q. And here when, so the resultant can be found in terms of the given forces and angle, that is the P, Q and alpha. Now we have to find out the direction. So we assumed the resultant is making some angle theta with the OA, that is the horizontal. Now we have to find out that angle. So we can find out any angle by using any trigonometric equation, but it is easy to find by using tan theta. So in the triangle, this is in this triangle OCD, the tan theta is equal to CD by OD. So CD we know that Q into sin alpha. OD is nothing but the P plus Q into cos alpha. So that we have to substitute. So substituting so tan theta is equal to CD by OD. And this OD is nothing but again it is OA plus AD. So we know the all values, the OA value, AD value and CD value. So CD is equal to Q into sin alpha and AD is equal to Q into cos alpha. So here tan theta is equal to Q into sin alpha by P plus Q into cos alpha. And when we know that tan theta, the theta value can be found by inversing that value. So theta is equal to tan inverse of the Q into sin alpha by P plus Q into cos alpha. This is the second equation. So previously we got equation 1 for the resultant force. Now we got the equation 2 for the direction of the resultant force. Now the equations 1 and 2 will give the magnitude and direction of the resultant force. So this will give the this equation holds good for any kind of two forces, that is two coplanar concurrent forces acting on a body with some included angle between them. This holds good to find out the resultant and also the the magnitude and the direction of the resultant. Now we got some special cases. So the case one is when P and Q are at right angles to each other. That is, the alpha is 90 degrees. That means the P is acting with Q at right angles, or the P and Q are the acting at right angles. That is, the angle between the P and Q is 90 degrees. So simply, if we substitute the value, R becomes R is equal to P plus P square plus Q square plus 2PQ into cos 90. Here the cos 90 value we know that it is 0. So that term will not be there. So here the 2PQ into cos alpha will become 0. Therefore R becomes under root of the P square plus Q square. So R is equal to under root of P square plus Q square. Or we can say that R square is equal to P square plus Q square. So here also what is happening is when P and Q act at right angles with each other, then the diagonal will become the diagonal of the right angle triangle. And we know that according to the Pythagoras theorem, the square of the diagonal is equal to square of the one side plus square of the other side. So one side will become the P and the other side is nothing but the Q. So then R square is equal to P square plus Q square, or R is equal to under root of the P square plus Q square. And now coming to the direction. So we know that tan theta. Tan theta is nothing but the what? Here Q into sin alpha by P plus Q into cos alpha. Here cos 90 is 0 and the sin 90 is equal to 1. So q into sin 90. So it becomes q. And here q into p plus q into cos alpha. So p plus q into cos 90. So it becomes, the term will become 0. Ultimately we'll get tan theta is equal to q by p. So here the tan of the angle made by the resultant is equal to the ratio of the forces. So q is one force, p is the other force. So generally we'll take the q is a smaller force and p is a bigger force. So it is, this ratio will become the tan theta, and theta becomes the tan inverse of the q by p. So in this case the tan of the angle becomes the ratio of forces, and r becomes under root of the p square plus q square. Now the next one is the second special case is if the forces are equal. That means the magnitude of the both forces are equal. That is P is equal to Q or Q is equal to P. Now what happens, we'll see. So we know that R is equal to P square plus Q square plus 2PQ into cos alpha. Here we have to substitute the Q is equal to P because Q and P are same. So in substituting the, wherever Q is there, we have to substitute with P. So first one is the P square, next one also P square plus 2 into P into cos alpha. So when 2P square is common, so first one is 2P square plus 2P square into cos alpha. So when we take the common as 2P square, so R becomes under root of the 2P square into 1 plus cos alpha. And we can write the cos alpha as like this also, that is 2 cos square alpha by 2 minus 1, because cos 2 alpha is equal to 2 cos square alpha minus 1. Similarly, the cos alpha will become the 2 cos square alpha by 2 minus 1. So that minus 1 and plus 1 will get cancelled, and it becomes only 2 into cos square alpha by 2. So already we got 2p square. So this is nothing but the 2p square into 2 cos square alpha by 2. So now we got the two terms and also p square term and cos square alpha by 2. So then r becomes 2p into cos alpha by 2. So this is the magnitude of the resultant. So r is equal to 2p into cos alpha by 2 when p is equal to q or the forces are equal. Now coming to the magnitude part, that is the magnitude is over. Now coming to the direction part, that tan theta is equal to p into sin alpha by p plus q into cos alpha. So here we got p into sin alpha by p plus p into cos alpha. So we got p is common. So if we take the p common in the denominator, it becomes p into 1 plus cos alpha. Numerator we got the p into sin alpha. That p and p will get cancelled, and it becomes the sin alpha by 1 plus cos alpha. And we know that sin 2 alpha is equal to 2 into sin alpha into cos alpha. Here the similarly the sin alpha is equal to, we can write as 2 into sin alpha by 2 into cos alpha by 2. Similarly we know that 1 plus cos alpha also equal to 2 into cos square alpha by 2. So here what is happening is, so 1 cos alpha by 2 will get cancelled, and 2 will get cancelled. It becomes sin alpha by 2 by cos alpha by 2. So that is nothing but the tan alpha by 2. Here tan theta is equal to tan alpha by 2, or nothing but the theta is equal to alpha by 2. Ultimately the angle with which the resultant acting is nothing but the half of the angle made by the forces, half of the angle between the two forces if P is equal to Q. So here in this case the resultant force bisects the angle between the forces. The resultant force R bisects the angle between the forces, that is P and P. So if the forces P and Q are equal, that is P is equal to Q or Q is equal to P, the R will become the 2P into cos alpha by 2, that is the magnitude, and the direction is simply the theta is equal to half of the angle between the forces, that is alpha by 2. So that is nothing but the, it makes an angle which is equal to half of the angle between the forces with the horizontal, that is theta is equal to alpha by 2. So this is the second case of a special situation, special case 2. Now we know that so in this way, so these are the cases where we can employ the parallelogram law of forces to find out the resultant of the two forces which are acting with some included angle between them. So there where R is equal to P square plus Q square plus 2PQ into cos alpha, and theta is equal to tan inverse of Q into sin alpha by P plus Q into cos alpha, and they are the special cases. Now in the other way also we can find out. So that is about by using the parallelogram law of forces. Now the, so for example, some forces, when in some cases more than two forces also may act. So when more than two forces are acting, then that parallelogram law will not be helpful and it will not be applicable. And in that case, we also can found the resultant of the forces by using the method of resolution of forces. So here what is happening is, we will resolve the forces into components. We will find out the horizontal component and vertical component for each force acting on the system. So here there is no limit. The forces need not be 3, 4 like that. Any number, for any number of forces also we can find out the horizontal component and vertical component. Then we will find out the algebraic sum of the horizontal component, that is sigma h, and also the algebraic sum of the vertical components, that is sigma v. And here r can be found by using the equation r is equal to under root of sigma h whole square plus sigma v whole square. So here r square becomes sigma h whole square plus sigma ev whole square. So here r becomes under root of sigma v square plus sigma h square. And here also theta can be found, that is the theta means the direction of the, that is the result, the magnitude of the resultant. Now the direction of the resultant can be found by tan theta is equal to sigma v by sigma h, and theta can be found by tan inverse of the sigma v by sigma h. And so here what is happening is, so in this way also we can found. So firstly, so in this way we can found for the any number of forces, and even if the P and Q will act, then it becomes only two forces. So and this method also can be applicable at two forces or three forces or any number of forces. But however, it will give the same. For example, if only two forces P and Q are acting, then the whatever is the resultant of the force that we will found by using the parallelogram law of forces and by using the method of resolution of forces will be same, and it gives the same value both in magnitude and direction. So here, for example, we have taken the two forces. One is the P force and the other is the Q force. So in the figure 1.2a, here the upper force is called as the Q force, and the force acting downward is called a P force. The P force is making an angle of alpha 1, and Q force is acting at an angle of alpha 2 with the horizontal. So here it is very important. The angle must be taken only from the x-axis. So we should consider the angle made by the force only with x-axis. Sometimes in the problem they may give some angles may be given with y-axis. In that case, we have to convert and find out the angle made by all the forces with x-axis, and only the angle made by the forces with x-axis only will be taken into consideration to find out the resultant force of a force system, and in case of the method of resolution. Now in the figure 1.2b, here the P force can be resolved into two components. One is the pH, that is the horizontal component acting parallel to the x-axis or acting horizontally, and that is also equal to, we know that P into cos alpha 1. And here one more thing, here pH is acting rightward, that is in the positive x direction, so it is taken to be plus value. So it is taken to be a positive value, so that is a plus. And Py is acting downwards, and Py is nothing but the P into sin alpha 1, and but it is acting downwards, that is in the negative y direction. So the sign taken as negative and its value is negative, so that is minus Py. And coming to the force Q, the horizontal component is acting, that is QH. QH is equal to Q into cos alpha 2. That will also act along the x-axis leftwards, that is in the negative x direction. So it is taken to be a minus value. So horizontal component of this Q is equal to minus QH. And coming to the vertical component QV. So QV is nothing but the Q into sin alpha by alpha 2. Q into sin alpha 2. However, it is acting upwards. So it is taken to be, that is nothing but the positive y direction. So it is a positive value. So like this, we have to find out the algebraic sum. So it is very important that In finding out the algebraic sum, the positive forces must be added and the negative forces must be subtracted. That is, the positive x component is added and the negative x component is subtracted. Similarly, the positive y component must be added and negative y component will be subtracted. So, if we once again I am repeating, if the force acts along the x-axis towards rightward, that is in the positive x direction, so it is a positive value. And if the horizontal force will act along the x-axis, that is in the leftward direction, that is nothing but in the negative x direction, it is taken to be negative. Then if any force, that is the vertical component of the force, acts in the positive y direction, that is upwards, it is taken to be positive. And if any component of y that is acting downwards, that is nothing but in the negative direction of the y, it is taken to be negative. So like this, so this sign convention we should follow in finding out the algebraic sum of the either horizontal forces or the vertical forces. And however, for tan theta, that will not be whether it is a positive or negative. So depending on the value of the theta, and so the quadrant can be decided again in the tan theta also, depending on the value of the x and y, whether it is positive or negative. If both x and y are positive, it will lying in the first quadrant. If the x is positive, sorry, first we go like this, and if the y is positive and x is negative, then it will lie in the second quadrant, and whatever the theta that is acting from the x axis in the second quadrant. Similarly, if both are negative, that is sigma v and sigma h both are negative, then the resultant will lie in the third quadrant, and that angle must be taken from the x axis. And in the fourth case, if the sigma h is positive and sigma v is negative, that is positive x and negative y, then the resultant will lie in the fourth quadrant, and the resultant will be acting in the fourth quadrant, and the angle must be taken only from the x axis. So here also the sigma h, that is nothing but the, so we have converted all the forces into their hard general components, and we found the algebraic sum, that is nothing but the sigma h. So sigma h is parallel to the x sigma h, and sigma v is nothing but the algebraic sum of the vertical components of all the forces. And now r, so in this triangle, so we can say that when sigma h and sigma v are acting at right angle with each other, then the diagonal can be found by using the equation that r square is equal to sigma h whole square plus sigma v whole square, or r is equal to under root of sigma h whole square plus sigma v whole square. In this way we can find out the magnitude of the resultant. Now in this figure also, tan theta, that is the angle made by the resultant with horizontal theta, can be found by tan theta, and here the tan theta will become the sigma v by sigma h. Sigma v is nothing but the algebraic sum of the vertical components of all the forces, and the sigma h is the horizontal component of all the forces. algebraic sum of the horizontal component of the all the forces. So tan theta will become the sigma v by sigma h, and accordingly, so and based on the signs of sigma v and sigma h, we have to decide the quadrant in which the result is acting, and wherever is the result, the quadrant may be either first quadrant or the second quadrant or the third quadrant or the fourth quadrant. Whatever the quadrant, the angle must be always taken from the x-axis. Accordingly, we can uh, point out a, that is, we can represent a resultant, and these problems can be, we'll say, in the next class. And so far we have studied about the parallelogram law of forces, and we have we have defined the parallelogram law, and we have defined the equation, we have derived an equation for the resultant force, that is magnitude is equal to under root of the p square plus q square plus 2pq into cos alpha, and the direction theta is equal to tan inverse q into sin alpha by p plus q into cos alpha. And we also studied about the some special cases. If the forces act at right angles, what is the value of r? The r becomes the under root of p plus q square, and tan theta will become the q by p, that is the ratio of the forces. And the second case is if the p is equal to q, the r becomes 2p into cos alpha by 2, and theta becomes alpha by 2. And we also studied the resultant of a given force system by method of resolution of forces. Here we have to firstly we have to find out the algebraic sum of the all the vertical components, that is sigma v, and the algebraic sum of the all the horizontal components of all the forces. Then the r can be found by using the equation r is equal to under root of sigma v square plus sigma h square, and tan theta is equal to sigma v by sigma h, nothing but the theta is equal to tan inverse sigma v by sigma h. In this way we have to find out the magnitude and direction. So today I am stopping at this point. So now I am, so thank you all.